Let's figure out the angle between two lines which are intersecting. Now, the funda over here is that dot product actually. So before I talk about anything else, I want you guys to understand when I talk about angle, or when we talk about angle, or when you talk about angle between lines, it is always the least possible angle. So this is theta, this is 180 minus theta, and this is 180 minus theta, right? And this 2 is theta. So theta being the least possible angle in all of this 4, actually 2. So that is what we are trying to figure out. Okay, that's the first thing. So the underlying principle or the concept that we are going to use over here is the dot product. So we know that if I know A and B, the vectors pointing in the direction of the lines, I can take the dot between them, which gives us AB cos of theta. So basically we are trying to figure out theta. So a bit of rearrangement, and we have the following result. Remember, we started off talking with the direction. That's all we need. And so either we'll get the equation of the lines, or we'll get the Cartesian form, or the direction ratios, or that even the direction cosine also. Even direction cosine can also work with this. Because whatever form, the direction that we get, it's okay. We can make use of all of these scenarios, or any one of this scenario, and figure out the angle between two lines. So starting off with, what if we have this? In this, what is the directional aspect? B, right? And so we have cos theta will be equal to B1, vector B1 dotted with vector B2. And we divide this with the magnitude of B1 and B2. And we will take the entire magnitude of this entire thing. That is, we are not considering the negative, we are just considering as a degree, as a number. This is one possibility. The second possibility is that they can give us direction ratio, direction cosine, or in the Cartesian form. So what you guys need to understand here is, where is the information given? There it was vectors, remember. There it was different. This is in vector form and all of that. These are in equation form. Here it is in Cartesian form, if not direction ratio, if not direction cosine. So direction ratio and direction cosine, they're similar. Cartesian form, we have the values in the denominators. So we have to pick those values, right? And we will have cos of theta is equal to magnitude of A1, A2 plus B1, B2. So if you remember dot product between two vectors, this was the result what we got, right? So it's the same thing in the numerator. We can see it over here also. It's a dot product divided by the magnitude. So let me do this way. Divided by, I'll write it over here. So square root of A1 square plus B1 square plus C1 square. Again, if you're fundamentally strong from the start, if you learn things properly, then this is very simple. A2 square plus B2 square plus C2 square. These are your magnitude or the length of the lines. Again, learn the vector concept properly. All this becomes very simple actually. It's an extension. It's literally an extension. That's it. Okay, if you understand that vectors, then this is very simple. Okay, guys. So either of this formula, depending on the scenario, can be used to find your angle. And yeah, by the way, this 2 is the magnitude of stuff. So might look weird, but so we're going to take the magnitude at the end of it. Okay, so you can pause, have a look, and copy this.